I want to find the moment of that 120-pound force about point O. And we'll remember that the moment is found by an r vector crossed with an f vector. And that r vector goes from the point O to anywhere along the line of action of the force. And the force vector is the force vector. So I can choose which r vector I use. I have basically two choices here. I can either go from O to B, or I can go from O to C. Now, actually, there's an infinite number of choices, but those are the two most reasonable ones to choose. Now, I'm going to choose O to C because that's just a single force, or I'm sorry, a single component of that um, um, position vector, and that's going to be 5i. That's going to make my cross product much easier if there's only one component of my moment arm. Okay, so again, you can choose from the point to anywhere along the line of action of the force. Choose the simplest r vector to make your cross product that much more easy. Now I have to write my force vector in Cartesian form. So I take that 120 times the r vector from B to C, which is going to be 4i minus 4j minus 2k. And again, that's the position vector from B to C. And I'm going to divide that by the square root of the sum of the squares, which gives me 6. 4 squared plus 4 squared plus 2 squared is 36. Square root of that is 6. Therefore, that force vector, written in Cartesian form, is 80i minus 80j minus 40k. So that's that 120-pound force written in Cartesian form. I'm using the r vector from O to C to make my life easier. Now I'm going to perform my cross product here. Okay, so I'm going to take 5i cross 80i. I cross I is 0, so I don't worry about that. Now I'm going to go 5i cross negative 80j. So I start with 5 and 80, just get my magnitude. Now I'm going to worry about the direction. I cross negative j, again, I, j, k. I'm going this way around the circle. That's positive. However, I have this negative sign in there, so that's going to go negative. So I'm going to put a negative k on this, right? I cross negative j gives me negative k. I cross negative k, let's go ahead and do that now. So we got 5 times 40. So now I'm going to go I, right? I, k, j. So this one I'm going this way. I'm going the negative way around the circle. However, I have this negative. Negative and negative make that a positive. So that one then becomes plus j, right? So I cross negative k gives me positive j. So my moment of this force then becomes 200j minus 400k. And again, my units on this are going to be foot-pounds. Now, again, let's talk a little bit about what that means. So this is a moment vector that has, we'll say, that much component in the y direction, and then twice that much um, in the z direction. Right? So it's on that YZ plane. None of this is in the x-axis. So that resultant moment, or I should just say the moment of that force is in that direction. Again, if we think about what that is, again, that's a thinking of your right thumb pointing in that direction. Your fingers on your right hand curl around that arrow in that direction. So that's actually a rotational vector going around that axis right there. So that's that force. That's the moment of that force. What that looks like about point O gives you that rotational vector as shown.